All right. Today we're going to be doing equation solving with these radicals. Y'all ready?
Kara.
Kara? Stop. All right. So we're going to be doing equation solving with these radicals. All right. First thing you want to do.
What? Get a smart word that works.
Yeah, I know it. First thing we want to do is we want to get the radical by itself, if it's not already. This one is, notice, this one's okay. What I mean by that is, on the side that it is on, you don't need any other stuff besides the radical. All right, so we're good with that. All right, then, second step. How can we get rid of a radical? How do you get rid of a square root? Square it, exactly. You square the square root to get rid of it. So, second thing, get rid of radical. All right, so they said square it. Now, it's okay to do it as long as you do it to both sides. Got to be both sides to be legal. All right, so what are we left with then when we square the square root? X plus 6. The square just deletes the square root bar. That's all. So you're left with whatever's under there every time. Okay? Equals what? 9, because we squared that 3. Okay? Michael, you be with me now. All right, then what will you do? Subtract. Look, I don't know why I'm doing a 3. Subtract.
Well, that's so easy.
And 3. All right, now, so let me add our steps. Solve for x, obviously. And then fourth, check the answer. Sometimes these answers, you'll get a number, but then when you plug it back in, it doesn't check out. So it's possible that the answers don't work. So you need to just glance and make sure that they work. Some of them you just glance and see. When that happens, it's called extraneous solutions. Extraneous solutions are when you got an answer, but then when you looked at it, it didn't make sense. So you might have to throw it out. Or if that happens, it'd be no solution. Can't do it, okay? But let's look. If I take my 3 and I put it back into the original problem, 3 into the original problem, look what it would be. Square root of 9, which is 3. So this one checks out. So what I'm saying, a lot of times you can just look at it and, oh yeah, I see it works. But make sure. Okay, let's do us another one. Now, first step, get that radical by itself. It has other junk over here. So we need to get rid of this. So what are we going to do? -1. We're moving that. We can't square until we get the radical by itself. All right, so we got cube root of x minus 5 equal to -2. Thank you. All right. Now, we're not a square root now. We're a cube root. So how do you think you get rid of a cube root?
Cube it.
You cube it. So we're going to cube both sides. Okay. Cube just deletes off the cube root bar. So you're just left with what's underneath, x minus 5. And what's -2 cubed?
-8.
Thank you. -8. All right. So we just cubed that. Now what? Plus 5. All right. So x has to equal, we think it equals -3, but we're going to check it. All right. I'm going to write it here and check it. All right. So we got the cube root of -3 minus 5 plus 1. All right. If I plug that back into the original, and equals -1 is what we want. So cube root of what, if I'm checking this, what is this? -8. So what is the cube root of negative 8? Look, we did it over here. Negative 2. Alright. Plus 1. Is that true? Yes. So our number is good. Every now and then it's not though. So look and see. So far so good? Alright. Alright, let's look at another one. First step, get the radical by itself. It's already there. So now what? Square it. That's the square root, so we're going to square both sides. Alright, so what have we got? Equals? Good. So watch that. That's easy to miss. 5 squared, 25. Alright, then. Alright, so x equals 29, we think. So I'm going to check it. Square root of 29 minus 4 is the same as the square root of 25. Check. Alright, most of y'all can glance at something like that and know that it's okay. Alright, the last couple, 2 or 3 problems are other situations that I need you to watch out for. Alright, so let's look at this one. First step is get radical by itself. So looking at that, what do I need to do first? Minus 2, good. Move the 2 over. So now we've got 4 on the cube root of x equals negative 2. Now what? Divide by 4. Radical is not by itself, so we got to get rid of that 4. He said divide by 4. Here's why, because that was 4 times, and we do the opposite. So that happens. So we got cube root of x equal to negative 1/2. Reduced. Now what? Cube both sides. Cube here, cube here. Alright. So here, this becomes x. I'll just tell you, negative 1/2 times negative 1/2 times negative 1/2 is negative 1/8. And I'll go ahead and tell you that checks out. Now. Take the negative off because why? No. It's not an exponent, so it's just negative. All right, I'm gonna pause this because the bell's fixing to ring. I'm not sure to pause it. Just hit. All right, so here, look, there's radicals on both sides, so you can just square both sides like this. Get rid of both of them. Square and square. So when that's the case, you just do this, and then that would leave what's under the bar on both sides. Like that. Okay? So then, what would you do? Minus 4. Alright, so she says move the 4, and I've got 3x equals x, and then what's this? Minus 10. Thank you. Alright, now subtract x. So we got 2x equals negative 10. Divide by 2. So x equals, okay, check it out. Go ahead. And I will be checking the answer. So that'd be square root . Okay. So when I go to check, I've got square root of negative 15 plus 4, which is the square root of negative 11. Over here, so that is okay, ma'am. these, these you do always have to check. Like on the homework, on the work that we're gonna do in just a minute, out of that whole back page that you got there, there's one that doesn't work. So every now and then there'll be one, but you don't know which one if you don't check it, because you'll get an answer. It'll look like it's an answer, so you kind of got to look and just make sure. All right, we got last one now. All right, now this last one is in exponent form. If we're solving when it's in exponent form, if I want to get rid of this 3/2, I raise it to the reciprocal. What's the reciprocal of that?
What's it?
2/3. So if I'm trying to get rid of a fraction exponent, raise it to the reciprocal, which is 2/3, and you'll do it to both sides. Here's what that does. It cancels and just leaves x. And then calculator can handle this for us. If somebody with a calculator would handle it. Thank you. 25, thank you, and thank you, Jesse, too. All right, so now here, and then like you were asking just a minute ago about checking, I mean, you look at this one. You can do 25 to the 3/2, type it in real quick, and it should just give you, so that's how you would test that. And it does give you that, so that one's okay. But again, on the homework sheet, one of them doesn't work, so you got to watch for it. All right, if you will. All right, so